Everyone, let's discuss about assembly and components in this lecture. Okay, so under this topic comes the design for assembly. That is, it is denoted by DFA. Uh, so once the parts are manufactured, they need to be assembled into sub-assemblies and products. The assembly process consists of two operations. Mainly, they are handling, and the second operation is insertion and fastening. So, the handling process involves grasping, orientation, and positioning of the object, and the it is followed by the insertion and fastening process. All right. So there are basically three types of assembly classified on the level of automation. First one is manual, second is automatic, and third is the robotic assembly. Now, in the manual assembly, the human operator at the workstation reaches and grasps the product from the tray and then moves, orients, and pre-positions the part for insertion. All right. The operator then places the parts together and fastens them, often with the help of some power tool. All right. In automatic assembly, handling is accomplished with the parts feeder, like a vibratory bowl that feeds the correct oriented parts for insertion to an automatic workhead, which in turn inserts the part. All right. And in the third type, that is robotic assembly, the handling and insertion of the part is done by robot arm under the computer control. All right. Now, the cost of assembly is determined by the number of parts in the assembly and the ease with which the parts can be handled, inserted, and fastened. The design can have strong influence in both areas. Reduction in the number of parts can be achieved by eliminating of parts, for example, replacing the screws and washers with the help of snap or press fits, and by combining several parts into a single component. All right. The ease of handling and insertion is achieved by designing so that the parts cannot be tangled or nested with each other, and by designing with symmetry in mind. Parts that do not require end-to-end orientation prior to insertion, as screw does, should be used if possible. Should only be used if possible. All right. Parts with complete rotation symmetry around the axis of insertion, for example, a washer, they are the best. When using automatic handling, it is better to make a part highly asymmetric if it cannot be made symmetrical. All right. And for the ease of insertion, the part should be made with chamfers or recesses for ease of alignment, and clearances should be generous to reduce the resistance in assembly. And self-locating features are important, as in providing unobstructed vision and room for hand access. All right. So, design for manufacturing guidelines is the next topic which we are going to study. It has basically three types of guidelines. The first one is general guidelines. Second one is guideline for handling the object, and third one is guideline for insertion of objects. So let's first discuss about the general guidelines. So there are basically 3 to 4 subtopics under this general guidelines. The first one is to minimize the total number of parts. Now, a part that is not required by the design is a part that does not need to be assembled. So, go through the list of parts in the assembly and identify those parts that are essential for the proof functioning of the product. All others are candidates of eliminating. All other candidates can be eliminated. All right. The criteria of an essential part, also called a theoretical part, are following. The first one is that the part must exhibit motion relative to another part that is declared essential. The second could be there is a fundamental reason that the part is made from a material different from all other parts. The next would be it would not be possible to assemble or disassemble the other parts unless this part is separate. That is, it is an essential connection between the parts. All right. The fourth guideline for being an essential part is maintenance of the product may require disassembly and replacement of part. And the fifth main point is the parts used only for fastening or connecting other parts are prime candidates for elimination. So these are the 5 guidelines according to by following which we can minimize the total number of parts. All right. The second general guideline is to minimize the assembly surfaces. How it can be done or why it is required? So to simplify the design so that fewer surfaces need to be prepared in assembly and all work on one surface is completed before moving to the next one. All right. Then the third general guideline is use sub-assemblies. Sub-assemblies can provide economies in assembly since there are fewer interfaces in final assembly. Alright, sub-assemblies can also be built and tested elsewhere and brought to the final assembly area. When sub-assemblies are purchased, they should be delivered fully assembled and tested, and products made from sub-assemblies are easier to repair by replacing the defective sub-assembly altogether. Alright, there is fourth one that is not written over here, that is the mistake proof the design and assembly. Mistake proof the design and assembly. Now what is meant by this? So it is an important goal in design for assembly is to ensure that the uh, assembly process is unambiguous so that the operator cannot make mistakes in assembling the components. Components should be designed so that they can be assembled in one way. The way to orient the part in grasping it should be obvious and it should not be capable of being assembled in the reverse direction. Alright, orientation, notches, asymmetrical holes and stops in assembly fixtures are common way to mistake proof the assembly process. Alright, so these were the general guidelines. Now let's talk about the guidelines for handling. Alright, so the first point in this is to avoid the separate fasteners or minimize fastener cost. Now, fasteners may amount to only 5% of the material cost of the product, and but the labor they require for proper handling in the assembly can reach 75% of the assembly cost. So the use of screws in assembly is expensive and snap fits should be used whenever possible. Alright, so when the design permits, use fewer large parts fasteners rather than several small ones. So costs associated with fasteners can be minimized by standardizing the few types and sizes of fasteners, fastener tools and fastener torque settings. When the product is assembled with a single type of screw fastener, it is possible to use auto feed power screwdrivers. Alright, the next guideline in this in guideline handlings is to minimize handling in assembly. So what is meant by this? The part should be designed to make the required position for insertion or joining ease to achieve. Okay, now since the number of positions required in assembly equates to increased equipment expense and greater risk of defect, quality parts should be made as symmetrical and as their function will allow. Alright, orientation can be assisted by design features that help to guide and locate parts in proper position. Parts that are handled by robots should have a flat, smooth top surface for vacuum grippers and an inner hole for steering or a cylindrical outer surface for gripper pickup. Alright, next let's come to the guidelines for insertion. So the first point in this is minimize assembly direction. Now what is meant by this? Uh, all products should be designed so that they can be assembled from one direction. Alright, rotation of an assembly requires extra time and motion and it may require additional transfer stations and fixtures. The best situation in assembly is when the parts are added in a top-down manner to create a Z-axis stack. Alright, the second point in this is to provide unobstructed access for the parts and tools. Uh, Parts and tools. TOOLES. Okay. Uh, So not only must the part be designed to fit in the prescribed location, but there must be an adequate assembly path for the part to be moved to this location. This also includes room for the operator's arm and tools, which in addition to screwdrivers could include wrenches or welding torches. If a worker has to go through contortions to perform an assembly operation, productivity and possibly product quality will suffer after a few hours of work. And the final point in guidelines for insertion is to maximize compliance in assembly. Now, what is meant by that? The excessive assembly force may be required when the parts are not identical or perfectly made. Allowance for this should be made in the product design. Designed in compliance feature include the use of generous tapers, chamfers, and radii. If possible, one of the components of the product can be designed as the part to which other parts are added and as the assembly fixture. This may require design features that are not needed for the product function. Okay, so this is what all there in the assembly and components. Thank you.